Yay, calculus. Yay. Number 52. X is defined as the cosine of t. Y is defined as t plus the sine of t. And we want to evaluate this, or find the tangent line at t equals negative pi over 4. All right, that looks good. Differentiation. Dx over dt equals the negative sine of t. Dy dt equals 1 plus cosine of t. And we'll evaluate these at t equals negative pi over 4. So that would be negative sine of negative pi over 4. Which negative pi over 4, how about like this? Here's our circle. Negative pi over 4 goes down just like that. So sine is going to equal negative radical 2 over 2. That's negative. And this negative. This is negative radical 2 over 2. That's just radical 2 over 2. dy dx, or sorry, dy dt, evaluated at t equals negative pi over 4, would be 1 plus cosine of negative pi over 4, which is the same as pi over 4. So it's x value. So that's just radical 2 over 2. So using our formula, dy dx being equal to dy dt over dx dt. And we want to evaluate this at t equals negative pi over 4. This is going to be dy dt, which will be 1 plus radical 2 over 2, all over dx dt, pardon me, radical 2 over 2. Let's use a little algebra to clean this up. This is really 2 over 2. So the top goes to 2 plus radical 2 over 2, divided by radical 2 over 2. Invert and multiply. These two go out. Wind up with 2 plus radical 2 all over radical 2, all of which are divisible by radical 2. So those two cancel. That goes to radical 2. That'll be radical 2 plus 1. And of course, this is our slope of our tangent line. Y equals mx plus b. M is satisfied at radical 2 plus 1. We need to find our y and our x. We'll substitute in negative pi over 4 here for x. Cosine of negative pi over 4 is radical 2 over 2. Substitute in t equals negative pi over 4 here. It'll be negative pi over 4 plus the sine of negative pi over 4 is minus radical 2 over 2. Now I'll have to do a little bit of algebra there. So we need to add these two and put them both over 4. So it's going to be negative pi over 4 plus minus this top and bottom by 2. 2 radical 2 over 4. And that'll be negative pi minus 2 radical 2 all over 4. That's our y bit. Negative pi minus 2 radical 2 all over 4. And plus b. So we're going to erase some of this so we have a little bit of room. So that's negative pi minus 2 radical 2 all over 4 equal to, multiplying these out, I'm going to distribute this radical 2 over here. So it'll be radical 2 times radical 2 is 2. Radical 2 times 1 is radical 2 all over 2 plus b. I want to subtract this from both sides. We're going to change this. I want this over 4. So that's going to be 4. That's going to be 2 radical 2. That'll be 4. Multiplying top and bottom by 2. So we'll wind up with minus pi minus 2 radical 2 all over 4. That's the first one. Subtracting this off, it's going to be minus 4 minus 2 radical 2 all over 4 still. B. Yes, this B. Minus pi minus 4 radical 2 minus 4 all over 4. And so then we can just rewrite our original statement. Our tangent line, y equals, and our slope is radical 2 plus 1. Our x is our x. And then since all these are negative, we'll just make this a minus out front. And that'll be pi plus 4 radical 2 plus 4 all over 4. And we can keep that like that. Or in fact, because we have all these 4s here, we can make this y equals radical 2 plus 1 x and be minus pi over 4 minus radical 2 plus or minus 1. Either one of those will do just fine. Moving on to 53. Good, we're done with that section. Writing to learn. All right. Here's A. We want to graph that function. So that's this piecewise. I had a little trouble with that before. Talking about from 0 to 1. So let's see, 0 to 1 and 1 to 2. So let's call this 1 and this 2. That negative 1 this is 0. So within this shaded region, x equals 0 to 1. We're going to have one particular graph, and that graph is f of x equals x. So that's that graph there, and that's equal on both sides. So that's closed circle, and then 2 minus x from 1 less than or equal to 2. So in this part of our domain, we're looking at negative, let's do this. It's just a line that hits at 2 and comes straight down. So we're talking about an open circle, goes there, and a closed circle here. All right, so these two form one continuous function. Is f continuous at x equals 1? That'd be yes. And that is because the limit from both sides approaches the same thing. So the limit as x approaches 1 from the positive side of f of x is 1. So as we're going this way, the value of our function is going up and is approaching 1. In fact, it equals 1 when we get there. And the limit as x approaches 1 from the negative side, f of x, I'm sorry, this one was from the positive side. This one's from the negative side. My fault. So this is pink, this is blue. I don't know if you can see the pink and blue. But they both equal 1. We had 3 criteria for continuity. 1, that these limits exist. They clearly do. 2, the limits are the same, which they do. And also the point is defined at that place. And we do know that because f is defined as x when x equals 1. So, and f of x equals 1. So just do f of 1 equals 1. So when x equals 1, our function equals 1, and the limit from both sides approaches 1. That's what we're looking for. And B, let's see. Well, A, there's the graph. B, our continuity criteria are done. Is it differentiable at x equals 0? No. Is it differentiable at x equals 1? We know it isn't because it's a point. We'd have several tangent lines at that point. So this is clearly a no for C. And the reason being is that it's a corner. You know, the corners, cusps, asymptotes, all non-differentiable. Great. It's A, B, and C.